Hey guys, it's Off1 here, and today we're going to be solving Decode Ways. In this problem, we're told that we're mapping every letter to a number. So for example, here we have A, and it's mapped to 1, B is mapped to 2, and Z is mapped to 26. So every letter in the alphabet is mapped to its position in the alphabet. So pretty straightforward there. The part where it gets tricky is that we're told that we're giving a string of numbers, and they're asking us to return the amount of ways we can decode it. So for example, for this one right here, we're told that there's two different ways to decode it, and that's 1, 1, 10, 6, 11, 10, and 6. And we're told that this is not a valid combination right here because of this 0, 6 here, because 0, 6 does not equal 6. So that's a small edge case we're going to have to take care of in the code, but other than that, it's pretty straightforward. Let me show you. So here I've written an example S, where the strings are 1, 2, 3, 2, and 1. And the way I'm going to approach this is by taking a look at each and every string, and then the next iteration I'm going to include the next part of the string, and so on until we reach the end. And for every time we do that, we want to calculate how many combinations we have up to this point. So for example, for 1, there's only one combination, and that is just 1. For 1 and 2, we have two different combinations. We could do 1 and 2, or we could read it as 12. For 1, 2, and 3, there's three combinations, and those would be just all single, or we could start with 12 and then 3, or we could do 1 and 23. And as you can see, these are all different ways of interpreting the string. So now we're going to do 1, 2, 3, and 2. And here's where we see that it doesn't follow a certain pattern, because you can't make a string out of 32. So I'll show you what I mean here. You can do 1, 2, 3, 2. You can do 12, 3, 2. Or you could do 1, 23, and 2. And the reason we can't have any more combinations is because, like I said before, we can't make a number out of 32 because that does not correlate to a letter in the alphabet. And then for our last number, 1, 2, 3, 2, and 1, we actually have 6 combinations, and I'm just going to write them out here. So here are the 6 different combinations you can do for this string of numbers, and here I'm just going to write how many combinations each number can produce. So for this first one, you can only do one different combination. When it's 1 and 2, you can have 2 different combinations. 1, 2, and 3, you can do 3 different combinations. 1, 2, 3, and 2 still only give 3 combinations. And then if you add a 1 at the end, you can have 6 combinations. So what pattern do we see here? Well, I'm sure most of you see it already. I'm sure you can see that this 6 here is the addition between these 2 different combinations, and that for this 3 here, all we have to do is add the previous 2 indexes, and we get the number of combinations for this. But what about for this 3 here? Why couldn't we add 3 and 2? Well, we can see that we couldn't make a double-digit number, so maybe that can be one of our conditions. So what we can say is, if we can't make a double-digit number, just rewrite whatever's in the previous index to the current index, since that means we can't make any new combinations. But what if our string here was modified, so instead of 1, 2, 3, and 2, it's 1, 2, 3, and 0? How many different combinations can we write from this? Well, we know that 30 is not a valid double-digit number, and 0 is not a valid single-digit number. So our actual combinations for this would be 0, since we can't make any combinations. So our 2 conditions can be, if we can't make a double-digit number, then just copy over the previous index's value, and if we can't make a double-digit number and our current number is 0, then we don't add our current index either. We can just leave it as 0. So I'm just going to rewrite all that on a cleaner page so you can see what I'm saying. So here I've initialized our results array, and in this results array, this first spot here is for our base case. The reason it's set to 1 is because when we check our first index on the string, we want to set this value equal to whatever is here. And obviously, if we can make a valid combination, we want to set it equal to 1. And I've also filled out all of the other combinations, so you can see that if we go to the end of the string, our valid combinations would be 6, and that's true as we saw in our example. And here's our pseudocode. So the way to read this is, if, let's say we're at 2 here, if we can make a valid double-digit number. So let's see, can we make a valid double-digit number using 2? Let's see, 1 and 2, is that valid? Yes. So what we would want to do in that scenario is set the current result that we're at, so we would be at index 2. We want to set it equal to result at I minus 2. So not this index here, but this index. So we will start with a 1 there. And now we go to this if statement. So if the current number we're looking at is not equal to 0, what we want to do is set it to our current result plus our result at the previous index. So in this scenario, it would be 1. So we would have 1 plus 1, and that would equal 2. The reason we check if it's not equal to 0 is because if you remember from the example, if we have a 0, then that means we can't really have any new combinations. And if we don't have a double-digit number that's valid either, we expect a 0 there. So when we initialize our array, all of these are going to be set to 0, except for the base case. So to give you another quick example of why we don't do this condition if we have 0, let's look at 1, 2, and 0. Well, let's start with 1. That makes one combination, just with 1. With 1 and 2, we can make two combinations. We can have them separate, or we can have them together as a 12. And with 1, 2, and 0, we cannot do this combination here where they're all separate because 0 is not mapped to anything. So this would be an invalid combination. But we can do 1 and 20. And also we couldn't do 12 and 0 for the same reason as above. So that would be invalid. So we would actually only want just one combination. And as you can see here, if we can make a double-digit number, we want to add our result at I minus 2. So that would be this in a scenario, which would be 1. And that is how many combinations we have here as well. So that's true, and it checks out. Our time complexity for this algorithm is going to be O of n. The reason for that is because we have to iterate through the whole string, and the string is of size n. And for space, similar thing, it would have to be O of n because our result array is going to be size n plus 1, which rounds down to n. But actually, as you can see, if you solved enough of these, you'll see that if we only use I minus 2 and I minus 1, we can do it in constant space because we can just store these in variables and update them as we go through the loops. So really our space is going to be O of 1 once we implement the code. And let me show you how to do that. To start, we're going to initialize two variables. One is going to keep track of our I minus 1, and the other is going to keep track of our I minus 2. So we're going to have previous 1, and we're going to set that equal to 1, and previous 2, and we're going to set that equal to 0. The reason previous 1 is set to 1 is because this would be pointing to our base case, and if you remember from our example, that would be 1, and previous 2 would be out of bounds, so for now, it's just 0. From here, we want to iterate through the whole string s. So we're going to do for I in range of length of s, and now we just want to make a new temporary variable. I'm just going to call it current, and we're going to initialize it to 0 for now. And now we want to do our if statements. So our first one is going to be if we can make a valid digit number, then we want to add our I minus 2 to it. So how do we write this condition? Well, first we have to make sure that I does not equal 0, because if it does, then that means we can't actually make a double-digit number to begin with. So just taking that out of the way. And also now we have to check if our substring at I minus 1 all the way to I plus 1, and all this means is the previous digit and all the way up to our current digit. I did I plus 1 because this would be not inclusive. So really, we would be doing just 2 digits like that. And what do we want to check? Well, we want to check that it's less than or equal to 26, because that is our greatest value in our array, and that would be z. But it's a string, so we want to do like that. And then we're going to copy the same thing here. We're going to check the previous two numbers and make sure that they're greater than or equal to 10. And from there, all we want to do is set our current equal to our previous 2. Now we check if the current number is 0. So now we check if the string at index I is not equal to 0. Then we want to add current plus previous 1, because that would be our index I minus 1. if you remember that from our pseudocode. And then from here, we just want to update our previous one and previous two variables. So previous two is going to be updated to previous one because we're moving forward in the array. And previous one is going to be updated to whatever our current is. And then at the end, we can just return our previous one because that would be our max at the very end. And that should work. Forgot to put an and right here, but now it should work. So as you can see, this code is pretty efficient. And now I'll go through the code manually. So for this problem, I've initialized this array here. And even though we're not using it, I just want to have it here just for clarification, because I know it can be kind of confusing to follow these pointers. So let's get started. So I've already initialized previous one and previous two over here, so we're good there. And now we want to iterate through the whole string s. And we're going to start with just this string here. So our current is going to be set to 0, which it already is. And now we want to check if we can make a valid double-digit number. Well, we're at I equals 0 still, so we can just skip this condition for this iteration. And now all we have to do is check, is the current index pointing to a 0? No, because it is a 1. So what we want to do is update our current to be equal to current plus previous 1, and that would be 1. And we can just set this to 1 as well, since that means that we found one combination. And now we just want to update our pointers. Previous 2 is going to be equal to previous 1. So previous 2 is going to be 1. And previous 1 is going to be equal to current, which they're both already 1, so we're good there. And now we go to the next iteration. So now we're looking at 2. So let's see. I does not equal 0 anymore. And we can just kind of forget about this condition now, since it's never going to apply again. And we just want to check if we can make a double-digit number. So if we take s at the previous index and our current index, what number does that make? Well, we can see that makes 12. And that is between 26 and 10, so that would be a valid double-digit number. So we want to update our current to be equal to previous 2, which is already 1, so we're good there. And now we check, is the current number we're looking at not equal to 0? So let's see, we're looking at 2, and 2 does not equal 0, so what we can do is add current is equal to current plus previous 1. Previous 1 is 1, current is 1, so our current is now going to be 2. And now we can update our second index here to be 2. So that means up to this point we have two different combinations. And we know that's true because we can make 1 and 2, or we can make 12. And now we want to update our pointers. So previous 2 is going to be equal to previous 1, and it's already 1. And previous 1 is going to be updated to our current. So now previous 1 is going to be 2. So now we're going to be looking at our third index, which is going to be 2. And now we check. Can we make a valid double-digit number? Well, let's see. If we combine the previous index with the current index, we can make a 22. And that is between 26 and 10, so we're good there. So we can update our current to be equal to previous 2. And previous 2 is 1, so that is updated to that. And now we check. Is the current index equal to 0? And we can see that 2 is not equal to 0, so this condition checks out. And now we can update our current to be current plus previous 1. So previous 1 is 2 and current is 1. So we want to update this to 3 because 2 plus 1 is 3. And now we can update our third index here to be 3, meaning we can make 3 different combinations. And we know that's true because 1, 2, 3, 1, and 23, or we could do 12 and 3. And all 3 of these are valid. And now we want to update our pointers. So previous 2 is going to be equal to previous 1, which is 2. And previous 1 is going to be updated to our current, and our current is 3, so now this is 3. And now we go to our last iteration, so now we're looking at 3. So let's see, current is equal to 0, we already did that, and now we check if we can make a valid double-digit number. So let's see, if we combine 2 and 3, we get 23, and that is a valid double-digit number. So what we can do is update our current to be equal to previous 2, so 0 gets updated to 2. And now we check, is the current number we're looking at equal to 0? Well, we're looking at a 3, so no. So we can add current plus previous 1, and then set that equal to current. So current is going to be 2 plus 3, which is 5. So we want to update this to 5. And also, at this fourth index, we could have a 5 here, meaning we have 5 different combinations. And we know that's true because we can have 1, 2, 2, and 3, 12, 2, and 3, 12 and 23, 1, 2, and 23, or we could have 1, 22, and 3. And all of these are valid combinations, so that checks out. And now we can update our pointers. So let's see, previous 2 is going to be updated to previous 1, which is 3, and previous 1 is going to be updated to current, which is 5. And now we just return previous 1, which would be 5. And that's true. If this video helped you in any way, please leave a like and subscribe. Thanks for watching, and I'll see you in the next video.